Alright, everybody. Talking about radians. Radians are cool. There's literally no reason why we use 360 as a measure for degrees, other than it divides by a lot of numbers. So we don't really need to worry about 360, especially if we're trying to actually use something that has to do with a circle to measure angles. So we teach you how to measure angles in a different way. So no reason for 360, but we are going to learn a thing called radians. Um, what we're going to do, we're going to make a radius of the circle. We're going to draw it. It's a beautiful radius. How about we try again, Moffat? There we go. Call it R. And I like this mouse way better than my school mouse. This is awesome. So what a radian is, the measure of 1 radian is if I took this same length and sort of wrapped it around a circle, as if I had a string this length and just sort of wrapped it around and it had an arc length of R, that's length around the outside, and then I just reattach it. So that angle that makes is 1 radian. So 1 radian is, just put in perspective, 1 radian is like about 57 degrees. And it might seem kind of weird, but I don't really care about how to change it to degrees yet. We'll talk about that in a second. So if you were to measure, in order to help us understand how many radians is in a degree exactly and why, you can almost imagine wrapping, let's just take a couple radians. So here's another radian, right? So this angle is 2 radians. Do another radian. It's about, each one of these is a radius. My drawing is obviously perfect, we keep going. 4, 5, 6, and you keep going. And honestly, if you do this perfectly, there's like 6 radians and a little bit of change left over. So what's cool about this is if I imagine cutting the circle in half here, there's 3 and a little bit is in a half circle. Now there's a number that we know has to do with circles that is a little over 3, and that's pi. There's pi radians. In 180 degrees. This mouse is so much more sensitive than what I'm used to at school. So there's pi radians in 180 degrees. So it's like 3.14 radians in 180 degrees. So we're going to actually use that to convert. And radians actually have to do with a circle. They're not just some random number that an ancient civilization picked because they liked how many times it divided. So yeah, we start measuring angles in radians a little bit, and then after that I've sufficiently got you all ready for trig and we can get rolling. So if we know pi radians are in 180 degrees, zoom in here, pi radians in 180 degrees, I'm going to teach you in the delta. The delta video is pretty good. So if you have trouble with my explanation, you can definitely watch the delta video and watch the show examples. But so let's do a problem. We'll convert, let's just say, I'm going to erase this here. I'm going to convert radians to degrees here. So let's say we convert 3 pi over 4ths radians into degrees. And you'd be like, Moffat, why are you calling it 3 pi over 4 radians? That sounds so weird. But if we get ourselves a picture of a circle here, 3 pi over 4 radians, like why would you even call it? It looks like there's like 6 and a little bit, or 2 pi radians in a circle, but why would you call it 3 pi over 4? Well, a lot of the ways people describe radians, because it's almost hard to match, it's almost hard to visualize radians the way I drew them. What's easier to do is, hopefully I can shrink this a little bit. I can. What's easier to do is, if you know that this is 0 radians, this is pi radians. Well, then this right here is halfway to pi. So this is just half of pi, pi over 2 radians. So 3 pi over 4 radians is 3/4 of the way to pi. So we oftentimes talk about it as in fractions of a half circle. Anyway, that's sort of a side note. It's really easy to do the conversion itself. You just take 3 pi over 4, you take your radians, and then you multiply it by the conversion. So there's 180 degrees in 1 radian, or in 1 pi radians, sorry. And then you do a little canceling. 3 times 180 over 4, plug that in. 3 times 180 over 4, and you would end up with 135 degrees. So it's, if you just multiply, the strategy is multiply by 180 over pi. Take your radians, multiply it by 180 over pi, and you'll be able to convert from radians back to degrees. So if I give you a crazy radian measure and you're like, I don't know how far along the circle that is, Moffat, you can always use this just to convert it back to degrees, which you do know. So I'm just trying to give you the tools should you go into a pre-calc class or any other class that uses trig at all, which is a lot of math classes. So yeah, it's usually multiply by 180 over pi, divide those pi's out, and then just do the multiplication. 3 times 180, 4, you got it. So there's my example, but use the delta video and the delta show example if you need it. I'll talk to you guys soon, and hopefully I'll be back shortly.